to 4 p.m. Okay, this is my schedule for the tutoring. Okay, you can get inside the virtual tutoring, of course. I don't know if you are doing before or no. I can, for example, Alejandro, you are there, right? Alejandro Martinez. Alejandro, you are here or no? I see your name. Bueno, Alejandro Martinez is our assigning tutor. So we have tutor, the same tutor, que Alejandro Martinez. I don't know exactly his schedule. I suppose that today I send the link. I see your name when you get inside this, but I don't know, it's not here. Well, okay, in another moment, Alejandro Martinez explain to you what is the schedule of him. Alejandro, it's not working for me. Okay, guys. Okay, listen. This is online class. For online class, you need good computer and good internet. So you have noticed Hilda Infante tried to already 6 times. Okay, try 7 times. And don't worry, don't bother us. Okay. Okay, you need good condition to take class online. So your computer is not good or your internet is not good, it's your problem. Okay, so this class is not for you. One more thing. Okay, I need to explain. No book. Don't spend money in the book. Only in Alex. Okay, she said que es $65, $66.99 or 65. I don't know. I don't hear anything. The majority of you hear me or no?
Yes.
Do you hear me or no?
Yes, I can hear you.
Yes.
Okay.
Yes, Professor.
Okay.
Yes.
Sorry, your microphone, you speak, yes. Okay, one more thing. Final text. So actually, how many tests we have in total right now? 8, no? Because it's 4 chapters, 2 on paper, and 1 on paper and 1 online per each chapter. 2 times 4 is 8, no? And the final is completely optional. It's only for the students who need to improve your grade. Suppose you are doing not well in one test. You need to improve. Professor, I don't want to get C in that class. Okay, take the final. And the final is only a 10 point with 100 points, sorry. Plus something, get this something depending of your participation. Can you answer the question good? No complain, okay? And also the attendance. Participation and attendance. Okay, by the way, today I don't necessarily take the attendance because some students sign in using guess. Because I need no name, I need your actual name to get the attendance. I have no time to say one by one because we have 4 students. The attendance. Missing the class, and maybe in the next you are not missing. You fix your problem of internet. Okay, any question? Well, I suppose you have questions, but not necessarily do it now. Throughout the semester, you say, Professor, could you repeat? I emphasize when is the test due. Okay. Any question? Any question? No question? No. Some people say no. When they
yes.
ask you, I need answer. No. I don't question, but activate the microphone or typing in the chat.
Professor, is the final written or is the final online on Alex?
Good question. Excellent question. It's reading. No online. Online. And Alex, you finish with the 1, 2, 3, and 4. Done. And this is reading. I send by email, and you send me the answer by email. Okay, super. I appreciate so much your question. Another question.
One more question, Professor, for the online test. For what platform will that be?
I don't understand very well, miss. Your speaker, blah, 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 blah. Come on, repeat again.
Okay. I was
Loud,
asking.
slowly.
Oh, okay, slowly. The online test, what platform will that take place on? Alex?
Alex. Do you want I show you? Do you want I open Alex and I show you?
If you could, I would appreciate it indeed.
No.
Yes.
Okay, my pleasure. It's my pleasure. It's my pleasure. Let me try. Let me open another window. Let me try to open another window. Okay. Alex. Okay. Again, open another window. Alex. There you go. Okay, so I want to share the screen. I want to share the screen. So far, I checking before the classes start. The only A student is signing inside. Let me share. Stop sharing. Okay, there you go. Okay, you go to the www.ale.com and using the course code I provide in the syllabus, you enroll in this. This is my class. Our class is called the name MAC1140 Summer 2020. No, 2022. Okay, the name is not important. 2020. No, it's 8 students. 2020, 22. Hello. Okay. Do you see or no, Mister?
Yes.
I do see. Thank you.
And so please let the professor try to get in. Okay. Too much student I have in this class, and too much problem. One other thing you want to know? I think you have questions. No? So we can start mathematics or no?
Professor, quick question. Are the exams in Alex structure?
No. No, you have at least 4 days to take that. No practice. Practice you can take with the frame. No problem. Never practice. Another question. Okay, suppose that we have no totally the information, but throughout the semester, I'll make the application full screen. Full screen. Do you see my webboard now? Full screen? Oh no. Oh, let me see. I do. Okay, I do. Okay. So far, no more questions, right? May I erase the board?
I do have one question. You said earlier that the final exam is optional, and I read that on the syllabus as well. However, in one of your earlier emails, it said that the final exam is mandatory. So I'm a little confused on which one it is.
Mandatory is this test.
Okay.
This is no mandatory. Suppose, Mister. Okay, you get A, and A. It's obvious that your final grade is A. Entonces you don't need to take the final. End the story. Suppose that you, for example, in one, you get B. Entonces, bueno, professor, but I want to get A, no B. Then you take the final. The final is extra point. Suppose the worst scenario, okay, you are doing the mess, and the final test don't count, and you get B, right? But the final test is always for help the student, never in decreasing degree, never. Okay, good.
Okay, thank you.
Okay, so I want to raise the board. And we start the mathematical part and no more question, no? No more question. You don't hesitate. Okay, okay. Okay. Okay, guys, this is the first topic that we are discussing today. It's a polynomial functions. Okay, polynomial function. Period. Polynomial function. Okay, somebody send to another student the link. Okay, what is that? Definition. It's important that you don't interrupt me. I understand it's the first day, no? And we have problems, no? Okay, polynomial function is a function like that. Fx equal, suppose that we have only the collection of different monomial, collection of monomial, no? A monomial is the algebraic expression that contains only one term. Suppose a sub m, x sub n, plus bam 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 plus a sub 0, x sub 0. What example of the monomial? Easy. I don't want to complicate abstract way. Suppose that you have 2x squared plus 3x plus 4. Okay, it's a trinomial, but it's a polynomial also. And by the way, this polynomial is formed by three monomial, 1, 2, 3, monomial, 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 and the degree of this monomial is 2 degree, and the degree of this monomial is 1, and the degree of this monomial is 0. What is the degree? The degree is equal to the exponent that we have in the monomial, right? This is 1 default, and this is no x, entonces I suppose that the exponent is 0. However, the degree of the entire polynomial is the degree of the higher monomial. So, and basically, suppose another example, f of x is equal to x cubed plus 3x squared plus 4x plus 11. This is polynomial degree 3. Degree 3. Why degree 3? Because this exponent is the degree. This is super important, guys. Degree, determine the degree of the polynomial. It's no polynomial. So to be polynomial, the exponent is always a whole number. So the exponent is always a whole number. What means to be whole number is 0, 1, 2, 3, 4, whole number to infinity. So never allow us fraction exponent, no fraction, no fraction, no fraction, and no negative number, negative exponent. So it's the most important characteristic to identify polynomial. It's a collection of monomial. The degree is always equal the exponent of the higher exponent of the monomial, and the exponent is always whole number, never fraction, and never negative. When you have fraction or negative, it's no polynomial. It's another kind of function. Okay, thank you. Anyway, please help me. Please tell me, you are all students with me. I suppose that you know very well this. Shui. Hilda Infante, of course. Okay. I read the chat. Oh, no more chat. Do you understand this basic idea? Okay. So my focusing in the today lecture is do the graphic, do the graph of the polynomial. Do the graph of polynomial function. Okay. Entonces, the graph of the polynomial function is relatively easy because the polynomial functions are continuous and smooth. Graph. Okay, that means, for example, polynomial function look like that, maybe. Smooth, never like that. The second is impossible in the polynomial. This hole que you see in another function, no. No hole, no corner, no cups, no gap. This gap, no. No gap, no hole, no corner. It's only continuous. The continuous means that we can do the graph without lifting the pencil from the paper. It's continuous, definition. And smooth means that we have no corner. Okay, it's smooth, like that, or like that, depending. You see now the most important thing to identification, the shape of the graph, continuous and smooth. Okay, so now to understand the graph of the polynomial, we need to understand very, very well end behavior. Everyone follow me so far or no? Everyone follow me so far? Come on. Stop.
Yes, yes.
Yeah, you follow me. Okay, good, very good, very good. What means end behavior? End behavior is important, very, very important to understand. I try to explain in detail now. Not only is valid for the polynomial functions, for every functions, but specifically in the polynomial. Look, what means end behavior? Suppose end behavior, example 1, to understand end behavior, suppose f of x equal -4 x to the 5th power plus 6 x to the 4th power plus 2x. Suppose this polynomial. No expect always the exponent is 5, 4, 3, 2. No. Maybe sometime happen that one term is missing. Okay, no problem. It's missing. Okay, entonces what is the end behavior? The end behavior is the dominant end behavior expression. It's equivalent to say dominant. What means dominant? Dominant means the term increasing faster and dominant the growth of the polynomial. It's obvious, it's no big deal, it's no secret. Que es the term que contain the higher exponent. This is the end behavior expression. -4 x to the 5th power. Do you understand this? And what is important this? It's important because end behavior means when the function value, when the x approaches to positive infinity or negative infinity. So I suppose hypothetically x is all real number. That's the domain. However, I suppose a huge number. Because the dominant value in the polynomial is the monomial that contains higher exponent and describe the end behavior. What means that? Let me try to understand graphically, geometrically, end behavior. Suppose this example, that the end behavior is equal -4 x to the 5th power. In that case, I can see that the exponent is odd number, is 5, and the coefficient exponent is an odd number, and the coefficient is -4, is a negative number. Therefore, this representation, the graphic part of that part, look like that. Look, I don't care exactly what happened in the middle, but the end behavior is when the x approaches to infinity in that direction, or when the x approaches to negative infinity in that direction. And I can see that the y is in this direction, approaches to negative infinity, and here y approaches to positive infinity. Is, you know, one easy way to call this is right down and left up. It's another possibility. And this situation happens under this condition. Coefficients are negative and exponent odd. Let me try to explain every possibility we have in this case. Okay, actually it's only 4 possibilities. Suppose another example, the end behavior is 4x to the 5th power. So now the coefficient is positive, 4, but the exponent again is odd number. The end behavior of our polynomial look like that. I put this because I don't know exactly what happened in the middle, but for sure I know what happened in the end behavior. It is right up and left down. This idea is clear or confusing? Come on, come on, come on, come on. When the x is a big number, y is also big number positive. However, when the x is negative big number, y is also negative big number. Get that one. That's it, no? But I want to know if you understand this idea or not. You want to understand this idea or not? A ver. Stop. Yes. Desiree Perez, say yes. Okay, guys, remember, your participation is important. I detecting the student is sleeping, right? Not today, but throughout the semester, I know that you are sleeping, you don't pay attention, you are the mess, okay? And don't expect good grade from me. And the final test, so you need to take, no extra. Only your participation is important, your attendance is important, you are present here with me every lecture. Don't missing any lecture. Okay, got it. Giovanni Palacios. Okay, another possibility is, suppose coefficient positive again, suppose 2, and the exponent even number. One example of this end behavior expression is equal maybe 4 x to the 6th power. Look, even exponent. Coefficient 2, you put 4. Sorry, it's 2. How look like the end behavior of this? Well, is look like that. Look like that. Okay, is right up and left up. Okay, because when the x is a huge number positive, y is also huge number positive. Look, goes up. And here, when the x is a huge negative number, y is a huge positive number. Up. Likewise, or similar, when the coefficient is negative, suppose negative 3, and exponent is also even, therefore, the end behavior expression, in this case is suppose negative 3 x to the 8th power, because it's even exponent. Look like that. It's down. It's right down and left down. Y down, because it's always negative. No? When the x approaches to positive huge number, y approaches to negative huge number. When the x approaches to negative infinity number, huge number, y approaches to negative infinity number, huge number, negative. Okay, entonces this is super important because give me roughly idea how look like the graph of the polynomial. And we verify anytime using software. I want to explain your moment, but this is super important. Everyone understand very well in behavior or no? Now let me see. Yes, Sergio Medina, he said yes. Another answer. Come on, answer me. Answer me. Yes, Luis Rincón, Giovanni, Sebastián. Who more? The other students, I suppose, can understand, right? So you don't say something to say yes, professor. Okay. Because it's easy. It's no big deal. It's super elementary. Okay, but let me verification si you understand or no. Another example. And you let me know if you understand or not. Example 2. I want to complicate a little bit. Suppose example 2. Example 2. Not always I give you the polynomial in expanding form. I give it in factory form. So this is a little bit more complicated. G of x is equal 1 over 4 x parentheses 2x minus 3 cubic and x plus 4 squared. Wow, what the hell? Okay, my first question is, what is the degree of this polynomial? Opinion? 3. No, not 3. 3 is wrong. The problem is you see this. And you see the higher point is 5. No, you are close. 5 no. 3 no. 5 no. No. 1 no. Okay. Let me explain. Suppose I spend a lot of time expand this some multiplication, foil. No. Okay, suppose what is the aim behavior? What is the aim behavior expression? What do you say? 104. No, 104 coefficients. Aim behavior. Wow, what happened in this class? Aim behavior. Okay. Listen to me. Aim behavior is when the x is a huge number, positive or negative. Okay, ese million, ese trillion, something. Entonces now, it's obvious that you can delete mentally negative 3 and positive 4 because this part is completely negligible. Because what is 3? See, we have x equal million, trillion. So now I rewrite the end behavior expression like that. 1 over 4 x times 2x cubic and x squared. Because 4 disappear, minus 3 disappear. Okay, let me try to manipulate a little bit that part. Now I can see, okay, 1 over 4 x, and this is 2 to the third power, is 8, and x to the third power, and x to the second power. And that's it. No, I condensing a little bit that part. This is 8, you know, 2 times 2 times 2, 3 times 8, 8 divided by 4 is 2. Now x1, 3, and 2 is x6. Do you see now? Okay. Now my question is, what is the degree of this polynomial? So you take S6, right? Degree 6. Because you take the degree of the aim behavior expression. Okay? And how look like the graph of this polynomial? Well. Coefficient is 2. Exponent 6 is even. For sure, I know that the graph look like that. Boom. Okay? It's right up, left up. Make sense? Yes. Sophia, Monday. Okay, no problem. Okay, little by little you improve. Little by little you progress. May I erase the board? Yes, big yes. Okay, another important, extremely important thing to do the graph of the polynomial is the zeros of the polynomial. What means zeros? Zero means the x-intercept, x-axis, intercept. And what is the formula, professor? The formula is you take the polynomial, you enforce it to be equal to 0, and you determine the points in which the graph crosses. Who make a noise? Ryan, no? You make a noise, Ryan? Okay, you put it mute. Don't forget to putting off the microphone. The only microphone que se on is my microphone. When you want to talk to me, yes. But when you want to make a noise, no. Okay, so basically is you find the x-axis intercept. Okay, the 0. What means 0? 0 means, look. Suppose that the graph of the polynomial look like that. Bam, bam, bam. This is the point. That point. And I suppose okay, this is the x-axis. Okay, it's the point in which the graph of the polynomial crosses or touch, depending, no? Sometimes touch, sometimes cross. And the formula is clear. The formula is this. You take the function, you enforce it to be 0, and solve for this equation. This is the zeros. Another is the y-intercept. The y-intercept is the point in which the graph of the polynomial crosses the y-axis. And the formula is easy. You evaluate it. Bam. This is super important formulas. And let's apply now in one specific example. Example number 3, no? Suppose now I have a polynomial like that. X cubed plus x squared minus 9x minus 9. I have equations. First of all, what is the degree of that polynomial, guys? Degree. What is the degree? What is the degree? 3, very well. What is the end behavior expression? End behavior expression. Okay, condensing the information when the x is too big number. What is the end behavior expression for this? Nobody can answer? Yeah? Excuse me, very well. This part. Why? What is the reason? Because this is the higher exponent, no? And the rest is totally neglected. Now, in that case, coefficient is 1, visible, and exponent is 3. Therefore, the graph of this polynomial look like that. Boom. Okay, it's right up and left down. And it's obvious. Okay, this is the end behavior. However, I want to investigate now that part. To investigate that part, we compute, why not, the x-intercept and the y-intercept. So that formula, look, that formula first, and that formula second. Okay, so say I take the polynomial, and you enforce it to be 0, and you solve this equation. For solving this equation, for now, I apply factorization. after I explain another super powerful way to do this. But so far, factorization. In this case, we have 4 terms, 1, 2, 3, 4. I apply factorization by grouping. Okay, grouping. The GCF in the first couple is x squared. We have x plus 1. And the GCF in the second couple is -9. We have x plus 1. Yeah, it's so clear like water. X plus 1 is common factor. Look, I factor out again. I have x plus 1 out. X squared minus 9 equal to 0. Now I finish. No, why not? Because I see here in that moment okay, we have the famous differences of a square. And we're using the formula that you very well know. It's a squared minus b squared is equal a plus b times a minus b. I suppose you remember very well that formula. This is differences of a square. Intermediate. Entonces hay factorization. What is to factor completely this polynomial x plus 1. Open 2 parentheses. Square root this guy is x. And the square root this guy is 3 plus 1 minus. Okay, now this is a crucial important moment, and we have 3 factors 1, 2, 3 equal to 0 is because each factor separately 1 by 1 is also 0. So you declare x plus 1 is 0. Okay, this is equivalent to say that x is -1, x plus 3 is 0. It's equivalent to say that x is -3, and x minus 3 equal to 0, que es equivalent to say that x is positive 3. Boom! Therefore, I am ready at least to plot that point. Let me using now a little bit an image that I have here about rectangular coordinate system. Look at that. Okay, I plot that point, okay, -1. Let me use a record. -1, -3, and positive 3. Remember that point are -1, 0, -3, 0, and positive 3, 0, because the assumption at the beginning was que y is 0. Okay? And that's it. No. I have more information. I have maybe y in a set formula. Is this formula. Look. That's super easy because the only thing that you should do is evaluate plugging in 0. Plugging in 0 is 0 cubic plus 0 square minus 9 times 0 minus 9. Es obvio que the only guy que stay alive is -9. But in this case, x is 0. The point is the point 0, -9. And 0, -9 in that paper, you cannot see very well because it's, is here -7, -8, -9. Okay, -9. That point is a point. That point is a point. Is 0, -9. And we have 4 points, and also I know the aim behavior of this polynomial is, I forgot, I have here, it's like that. Look, aim behavior is +1 and odd exponent, so I suppose que look like that. No. Let me start here. It's left down. Okay, this point is the y in a set, and this is another x in a set. Shui. And this is approximately, the graph of this polynomial. Do you understand the idea or no? So the only thing, okay, yes, good. But I have more, guys. More to help you. I don't know if you are familiar. Yes, Sebastian Gomez. Say yeah. Entonces, I don't know if you are familiar with the one software. Okay, yes, yes. Okay, thank you for your participation. Silvana Rodriguez, yes. Are you familiar with the Desmos? Or you never see before in your life? Desmos. Yes, Marlon say yes. Okay, entonces we can using, so we know, yes I have, no, everyone have because it's online. It's online, you don't need to download anything, no. I want to show you now how you are doing the graph of this polynomial using Desmos and how I want, can you show me your word in the text? Not like that, not by hand anymore. No, please. Let me show you. Okay, there you go. Okay, sorry. Desmos. Do you see Desmos?
Yes.
Es super easy. You open your browser, Google Chrome, Firefox, or whatever, and you type in Desmos.com. Bam! And it's a free, beautiful, fantastic, online graphical grid. Okay? And you have to learn working efficiently with this in calculus and in pre-calculus. For example, I have different examples. Example one, okay, put in this script. Example one is the example we did before. Okay, I type in the polynomial and the specific point that we found, 1, 2, 3, x intercept and 1 y intercept. Boom, look at that. Boom. This is the graph. Okay. And behavior is clear, is right up and left down. No? And the point x intercept, negative 3,0, negative 1,0, 3,0. And the y intercept, 0,9. End of story. If you want to share with me in the test this image, you go here and you click share the graphic. And you export like an image, and you try to find the size you want, see medium or large or the way you prefer, and you click here and download like a folder of the image and you attach to the reading test, and that's it. Good or not good? Okay, super good. I like that.
Super good.
Beautiful. Okay, now I want to solve the second example. Pero no. Let's move on again to the whiteboard. You see, I solve in the whiteboard, and you immediately go back to Desmos, no? Okay. Wow. Whiteboard now. Okay. Whiteboard now. Do you see whiteboard or no? Yes or no? Yes. I want to erase everything. Now let's open one more. Example, I suppose it's 4 of the lecture, but actually it's the second in the Desmos, but it's okay. Example 4. Example 4 is, well, f of x or g of x or h of x. It doesn't matter the name of the function. H of x is x to the 4th power minus 4x to the 7th power. Question number 1. What is the degree of this polynomial? 4. Very well. The majority of you say 4. What is the end behavior expression? What is the end behavior expression? No, 4 no. Just 4? The end behavior expression is 4? No, 4 no. 4 is a constant. X to the 4th power. Good. X to the 4th power. You take the monomial that contains the greatest exponent, the higher exponent. Super. And this gives me the information about the end behavior. Okay, entonces coefficient is 1, invisible 1 we have here, and exponent is even. Entonces I suppose que my end behavior look like that. Boom, 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 like that. It's right up, left up. Right? Now, after that, determine the zeros. Silvana say yes. Determine the zeros. The zero is the equivalent to, say, the x-intercept. And the formula is h of x equals 0. Is, in our specific example, x to the 4th power minus 4x to the 2nd power equal to 7. So you take the entire expression, force it to be 0, and now I try to, using my skill in algebra, to solving this equation. Okay, by the way, 4-degree equation, but okay, this is easy, no big deal. You see the great common factor. The great common factor is obvious que es x squared, and you factor out x squared, and we have x squared minus 4. I'm feeling no. Again, the famous differences of squares. Okay, get that part. Your factorization to binomial xx 2 plus or minus. I suppose que everyone follow me, yes or no? After that, you separate. X squared equals 0. It's equivalent to, say, x equals 0 because you apply square root both sides. But the problem is that this is 0 and 0. So it's important to understand this new idea that you never see before in your life, that the multiplicity is 2. Why 2? Because these 2 appear like a 2. 2 is like a 0, 0. So actually, my polynomial contains degree 4, you know. So we expect, not exactly, but we expect 4 solutions, 4 zeros. Yeah. So you count, for example, the multiplicity. Multiplicity is, que, well, let me finish. Suppose x plus 2 equals 0, que is the second factor. Is equivalent to, say, x equals negative 2. And the third factor is x minus 2 equals 0, que is equivalent to, say, x equals positive 2. What is the difference? The difference is we have 4 zeros. However, it's like it says 0, 0, and negative 2, positive 2. But when it's repeated, you consider it one time. And the only thing that you indicate is the multiplicity. How many times this number is 0? Multiplicity m, multiplicity is 2. Here, multiplicity is 1 because negative 1 is only one time, and multiplicity 1 is only one time. Multiplicity 1. So what is important the multiplicity? It's important because the multiplicity indicates us if the polynomial graph touch or cross the graph. Let me explain in detail this. When the multiplicity is even number, the graph touch. However, when the multiplicity is odd number, the graph cross. Similar to the thing we are doing in the example 1. In the example 1, you never see before multiplicity 2. This is my first example in which you see. I promise you see more examples in the multiplicity 2, 3, 4, 5. However, touch. So what is the idea? I don't understand very well, Professor. Well, the idea is, suppose that this is the x-axis. I don't care for the moment the y-axis. And we have 0 here, 1 and 2. And here we have negative 1 and negative 2. Yes, so I know that the 0 is in 0 multiplicity 2 touch, and negative 2 and positive 2 close. And also I know very well the end behavior. Therefore, our graph, in my opinion, look like that. End behavior, cross, touch, and cross. Do you understand very well this? My sketch is not good. I guarantee you that this is completely symmetric. Look, this is my y-axis. Look, this is my y-axis. Okay, by the way, my y-axis, if you want to find the y-intercept, you evaluate the function at 0. The name of the function is h function, evaluating 0, plugging in 0, is 0 to the 4th power minus 4 times 0 to the 2nd power. Es obvio que es 0. And 0, 0. 0, is, I am the class, but I cannot hear anything. Okay? Because your microphone doesn't work, maybe. Or you have problem with the internet or something. You need to make the decisions. You drop the class or you continue. Okay? Maybe I forgot to say something. Oh yeah, I forgot recording this lecture. I forgot recording or not?